So here we have the unit circle that we discussed in the previous section. And again, the definition of a unit circle, the reason we call it a unit is because the radius has a unit of 1, kind of the simplest version we can think of. And so from the center of this circle here, going out in any direction will be a distance of 1 from the center out to the edge of a circle. So kind of putting some points on here, if I go to the right 1, well, that coordinate point is 1, 0. Again, I'm thinking of the x and y axis. So that point is 1, 0. This point is 0, 1. This point is negative 1, 0. Here I'm going to go down 1, so 0, negative 1. And then this is just an example of a radius, just to show that from the center to anywhere on the circle is going to be a distance of 1. And so let's go ahead and think about the radius where it's drawn there. And let's think about our x distance and our y distance. And so if I went to the right x amount and up y amounts, that would get me to this coordinate point where the hypotenuse there would still be a distance of 1. And this is kind of generic here. We don't have an actual x and y that I used. I just used x and y to represent any x and any y. And so this x distance right here is my x coordinate. This y distance here is my y coordinate. And then we want to remember that the x coordinate in a unit circle can be represented by the cosine of theta, and the y coordinate can be represented by the sine of theta. And then theta is just going to be this angle right there. Okay, let's go ahead and take all of this information and kind of see if there's something interesting we can do with it and something interesting we can get out of it that's useful in other scenarios. So I'm going to think back to the Pythagorean theorem. And the Pythagorean theorem says that in a right triangle, which we do have here, one leg squared plus another leg squared is equal to the hypotenuse squared. So in this situation right here, we have, well, one leg, x squared, plus the other leg, y squared, is equal to the hypotenuse squared. Okay, so first of all, how about just 1 squared? Well, 1 squared is just 1, so let's just go ahead and simplify that. So 1 squared is 1. Now let's think about, well, what can I replace x and y with? What else do we know about x and y here? Well, x is cosine of theta, y is sine of theta. So if x is just the cosine of theta, well then I guess I can replace x with the cosine of theta. And what we really have is cosine of theta squared. Now whenever I'm going to square a trig function, we can write it in a little bit easier way. So instead of cosine theta squared, we can actually write that as cosine squared theta, and that's the same thing. It's just a little bit simpler to write. Okay, and then same thing here, so I'm going to go y squared. Well, what is y? Well, my y value is equivalent to my sine value. So instead of y squared, well, let's just call it sine of theta squared. And again, if we ever have a trig function that is going to be squared, we can write it a little bit simpler. Instead of sine of theta squared, we can just go ahead and stick that squared between the sine and the theta. So sine squared theta. Okay, and that's going to be the same thing. And then here I have that cosine squared theta plus sine squared of theta is equal to 1. And this is called the Pythagorean identity. And the Pythagorean identity is going to help us to solve for either an unknown cosine or an unknown sine. So that's going to be really helpful in a lot of different situations. So here is an example where we could use the trig identity to solve for something that we don't know. So in this example, we have that the cosine of theta is equal to 1/2. And let's just kind of stop there with that piece of information. So the cosine of theta is equal to 1/2. Okay, now we want to remember, well, how do the cosine of theta and the sine theta correlate to coordinate points? Well, remember the cosine of theta is your x value, the sine of theta is your y value. So essentially we're given our x value is 1/2, and we want to find our sine of theta, so we essentially want to find the y value. So if I'm given essentially an x value of 1/2, then that means from the center here, I want to move out 1/2, and again we're going to be thinking of our unit circle here. So if the unit circle has a radius of 1, and I have an x value of 1/2, then I'm going to go out about half right there. And so that is my x value. Now I want to get to a point on the circle. So I guess to get to a point on the circle, I could either rise up some y amounts and get to this coordinate point up here, or I could go down some amounts and get to some point over here where that green y would be negative. But here's where this second piece of information comes into play. So when I'm looking at that second piece of information, it says theta is in quadrant 1. Theta is in quadrant 1. Well, up here is quadrant 1. And I just went ahead and added in a picture of all of the quadrants here. So quadrant 1 is that first quadrant, quadrant 2, quadrant 3, quadrant 4. So if I'm in quadrant 1, that means I'm going to be in this quadrant right here, which means that the scenario we're talking about is a positive y value, and I'm not talking about this one down here, so I'm going to go ahead and get rid of that. So I know that I am going to be talking about this coordinate point up here, where I have a positive x and a positive y. And I actually already know that my x value is 1/2, and really it's saying, well, what is that y value? What is that? What is that sine of theta, that y value? That's what I'm trying to find. Okay, and in order to find this, we're essentially going to use the Pythagorean theorem, which we kind of translated into the Pythagorean identity. And the Pythagorean identity says cosine of theta squared plus sine squared of theta is equal to 1. And so now I'm going to say, okay, well, what's the cosine squared of theta, or cosine theta squared? That's the same thing. So my cosine of theta was 1/2. So using this Pythagorean identity, which is essentially the Pythagorean theorem, I'm going to go 1/2 squared plus sine squared of theta, okay, well that's essentially my y value that I want to find, is equal to 1. And again, that was because the hypotenuse is 1 squared, which is just 1. Okay, so 1 over 2 squared, that's 1 times 1 is 1, over 2 times 2 squared, or sorry, 2 times 2, or 2 squared, which is 4. Okay, plus sine squared of theta is equal to 1. Okay, from here, let's just kind of finish out this algebra. So I'm going to be subtracting 1/4 from both sides, subtracting 1/4. So now I just have sine squared theta is equal to 1 whole minus 1/4 would be 3 over 4. Or you might think of that as 4 over 4. That 1 is really 4 over 4. Minus 1 over 4 would leave me with 3 over 4. Okay, I'm just about there, but remember, what are we trying to solve for? I'm trying to solve for sine of theta. Right now I have sine squared of theta. So I'm getting close, but I want that sine squared of theta to be just sine of theta. So what I need to do is I need to get rid of that squared somehow. And the way we undo a squared is by taking the square root. So if I took the square root, then that would cancel out the square and I would be left with just sine. But if I do something to the left side, then I have to do it to the right as well. Okay, let's go ahead and take a look at what I have over here. So first of all, whenever I take the square root of both sides, then I get a plus or a minus. It could be positive, it could be negative. And let's think about the root of both the numerator and the denominator. So the square root of 3 is, well, I don't really know, the square root of 3. And what's the square root of 4? Ah, well, that's easy. That's 2. And so as we can see, we sort of get two different solutions. Either positive root 3 over 2 or negative root 3 over 2, just like we saw before, because I could go up positive to get on the circle, or I could go down negative to get on the circle. However, we were told that it was in quadrant 1. And in quadrant 1, my y value is positive. So in quadrant 1, my y value is positive, so therefore I want the positive version of this, and I'm going to go ahead and take off the negative because that would not put it in quadrant 1. And so my y value here is going to be root 3 over 2. So I could come back up here and I could say, okay, I know what my sine of theta is. I know what my y value is here. It is root 3 over 2. And so I was told what my cosine of theta was, and I found what my sine of theta was. Okay, here's another example. I am given that the cosine of theta is 3 over 8. And so I have my unit circle over here. Unit meaning that's from the center to each of the edges is going to be a value of 1. 3 over 8 is a bit less than 4 over 8, which would be 1/2. So 3 over 8 is a bit less than 1/2. So from this center here, I know that I'm going to go out an x value that's a bit less than 1/2. So we can just kind of estimate there. It doesn't matter too much, but somewhere around there to be 3 over 8. Okay, now I know what my x value is. I want to find what my y value is in order to get to a point on the circle. So when I go to the right, I could either go up to get on the circle, or I could go down to get on the circle. So my y value could either be positive if it was in quadrant 1, or it could be negative if it was in quadrant 2. Quadrant 4. This is quadrant 4 down here. Okay, so let's go ahead and take a look at what quadrant it's in. So it says theta is in quadrant 4. So in order to get to quadrant 4, I'm going to be going down, not up, because that would be quadrant 1. So I'm going to be going down. So I know that my y value, or my sine of theta, is going to be negative. And again, that's because it's in quadrant 4. So let's go ahead and say, okay, I know my y value is going to be going down, so I know it's going to be negative. So in the end, I know I'm going to take the negative version of whatever I end up with. So now I'm going to use the Pythagorean identity, which is essentially just the Pythagorean theorem. So if I kind of make my triangle here with a hypotenuse of 1, I'm essentially just using the Pythagorean theorem. And now, so this says that the cosine squared of theta is where I start, and my cosine of theta is 3 over 8. So that's going to be 3 out of 8 squared plus sine squared theta equals 1. And again, that's 1 over there because 1 squared is 1. Okay, so 3 over 8 squared, that's 3 squared is 9, over 8 squared is 64, plus sine squared of theta is equal to 1. Okay, continuing my algebra here, I'm going to subtract 9 over 64, subtract 9 over 64. Left side I have just sine squared of theta is equal to, on the right, I maybe have to think of some fraction work here. Let's go ahead and think of this value of 1 as with a common denominator of 64. So I'm going to think of that 1 as really 64 over 64, because that would be the same as 1. And then I'm going to go ahead and subtract that 9 over 64. So this is perhaps my mental math or my little off to the side math. So I'm going to go 64 minus 9. Well, 64 minus 10 is 54. So 64 minus 9 is 55. So that's going to be 55 over 64. All right, and I'm just about there. But right now, I have sine squared isolated, or sine squared solved for. But of course, I want to find the sine of theta, the sine of theta. So to get rid of that square, I'm going to go ahead and take the square root, because those are opposites. Whatever I do to one side, I have to do to the other. So I'm just about there. Now I have the sine of theta is equal to, when I take the square root of both sides, then that's going to leave me with a plus or minus. And I'm taking the square root of 55 over 64. So the square root of 55 is, well, I don't really know, root 55, because it's not a perfect square. The square root of 64 is 8. Okay, and just like from our picture, we see that, well, I could go up and get a positive y value, or I could go down and get a negative y value. And in our case, our y value is in quadrant 4. So in quadrant 4, that's going to be a negative y value. So in our case, we want a negative. And so the sine of theta here, or my y value, is negative root 55 over 8. Now, notice that we're not taking the inverse sign because I'm not solving for theta, but my goal instead is just to find sine of theta, which I've done. I've solved for sine of theta. If, for example, it did say to just solve for theta, then I could take the inverse sine of negative root 55 over 8, and I would find theta. But we're just kind of keeping it a bit more simple for right now, and we're just finding sine of theta, so that means I'm done. Here we have another example. This time we are given the sine of theta. Remember, sine of theta is like your y value. So my sine of theta is negative root 3 over 2, or my y value is negative root 3 over 2. And you could maybe plug it into the calculator to get some kind of an idea of about what value that is, but it's about 0.86, or maybe a little bit more than 3/4, but it's still less than 1. So, and on the unit circle here, from the center in any direction out to the circle would be a distance of 1. So I'm going to be going down since it's negative, and sine of theta is a y value. So I'm going to be going down a distance that's about 0.8 or so. So I'm going to go down a distance, a y value, down a distance of about 0.8 or so. So what that means is I'm going to be looking for some point on the circle that hits either there or there. But then, when I see what quadrant I'm in, I know that I want my theta to be in quadrant 3. So quadrant 3 is the left side of my two options there. So quadrant 3, I'm just going to go ahead and kind of erase this and put on the point that I want there. So I know that quadrant 3 is going to be a point somewhere around here. And this y distance, I'm going to go ahead and go kind of from the x-axis there. So that y distance is going to be the negative root 3 over 2. So that's going to be my negative root 3 over 2. And what I'm trying to find is this x distance right here. So we need to figure out what that is. And again, the x is like my cosine of theta, so that's what I'm trying to find. Okay, so I have my triangle here. I can go ahead and put the hypotenuse to be 1. And now I'm essentially going to use the Pythagorean theorem or the Pythagorean identity to solve this. So cosine of theta, well, cosine is what I'm trying to find. That's my x value here. So that's what I don't know. So I can go ahead and leave cosine as just cosine. And then the Pythagorean identity says to start with cosine squared. Now I have plus sine squared, and my sine is going to be negative root 3 over 2, so that's my sine of theta. But then the Pythagorean identity says that it's sine squared of theta, so I'm going to go ahead and square that. And then that's equal to 1. All right, so we've got cosine squared theta. Okay, now when I'm going to square that negative root 3 over 2, first of all, a negative times a negative is a positive, so I know I'm going to get a positive value. Then I have root 3 times root 3, and you might perhaps think of it like this. Root 3 times root 3, well, that's sort of like root 9, which is just 3. Okay, so I'm going to get a 3 on top. Then on the denominator, that's a 2 squared, which is 4. So I'm here. Okay, and now we're just going to kind of solve this. So I'm going to subtract 3 over 4, subtract 3 over 4. Now I've got a cosine squared of theta. And that's equal to, and again, maybe kind of like writing out my thought process here, 1 minus 3 over 4 is like saying 4 over 4 minus 3 over 4, which would be 1/4. And that's why I get 1/4 right here. And I'm just about there, but I need to make sure that I'm solving for cosine of theta. Right now I've solved for cosine squared of theta, but I want to solve for cosine of theta. And so to get rid of the square, I'm going to take the square root and take the square root on both sides. Okay, now I've got just the cosine of theta, because my square and my square root canceled out, is equal to, whenever we take the root of both sides, that's going to be a plus or a minus. Now here, I want to take the square root of the top and the square root of the bottom. So the square root of 1, well, that's just 1. The square root of 4, well, that's just 2. And now I could think, okay, well, maybe it's either the positive 1/2 or the negative 1/2. But here's where I come back. Let me get my laser here. Here's where I come back to this piece of information that says theta is in quadrant 3. Well, theta is in quadrant 3. What are we finding? Cosine. Cosine is an x value. In quadrant 3, should my x value be positive or negative? Well, x is negative in quadrant 3. X is negative in quadrant 3. Therefore, I want the negative value here, and the cosine of theta is negative 1/2. Here's just a summary of all 4 of our quadrants, quadrant 1, 2, 3, and 4, and what the signs positive and negative are of our coordinates. And so thinking in quadrant 1, I'm going to be going to the right and up, so that's a positive x value and a positive y value, which means I'm going to have a positive cosine and a positive sine. In quadrant 2, I'm going to be moving to the left and up, so left would be a negative x value, and up would be a positive y value. So I'm going to have a negative cosine of theta and a positive sine of theta. Here's quadrant 3 right here. I'm going to be moving to the left, so a negative in the x direction, and down, so a negative in the y direction. So my x is going to be negative, my y is going to be negative, which means my cosine of theta is negative and my sine of theta is negative. Quadrant 4, I'm moving to the right, positive direction on the x, and down, negative direction on the y. So that means positive on the x, negative on the y, or positive on the x, or positive on the cosine of theta, and negative on the sine of theta.